Hello everybody, and welcome to our video discussing how we calculate state school funding aid in Oklahoma. We're going to look at the funding formula and work our way through the different parts of the funding formula in this video. So the first thing you see here is the calculating state aid formula sheet. You will need a copy of this sheet for each of your districts. As you work through this video, what I would encourage you to do is to actually use an extra copy of this sheet and work the demonstration as you go through so that you can see what you're doing, even though the demonstration is going to be in this video. With each of your districts, we have 5 districts, you will have these data, and we will work through most of these data in the funding formula we do not use the stuff here on the left dealing with the ethnic makeup of our school or the number of administrators and teachers. That's just extra information right now, but we're not going to use that in what we do. So let us take a look then at the actual funding formula, and as we go through this, we're going to talk about what we call equity. And this is an equity formula, it's an equalization formula. And so when we say equalization and equity, we're not talking about the same thing. So equal means treating people equally. Equity means treating unequals unequally until they become equal. And so what we mean by that is we know that some students, let's take an 8th grade class. If you have an 8th grade class, as a teacher, you realize that you have students who are working above the 8th grade level, and you have students who are working below the 8th grade level. And so while we're going to teach the whole class, we're going to spend a little bit of time giving something to those above to help further them. That's just ethical, in my opinion, that we do that. But we're going to spend extra time trying to help the students catch up. Okay, and that is equity. That's treating those unequal, those who are behind, unequally, giving them extra time until they catch up where they should be. The reason this formula is an equity formula is because we take into consideration what districts can make on their own through local taxes, and we subtract that from what the state is going to give them. So there are 3 basic ways that districts make money in Oklahoma. It's through local taxes, state funding, and federal money. On average, districts in Oklahoma receive about 10% of their money from the federal government. The other 90% is divided up between local and state funds. And it all depends on where the district falls. Some districts have very high local funds, and as we will see, do not receive any money from the state. We call that going off the formula or breaking the formula. And other districts are in the reverse of that, on the other end of the spectrum, where they have very little local monies and practically receive all their money from the state. So we're going to look at 3 parts of the formula, and within 2 of these parts we're going to concentrate on how this is an equity formula and what we mean by that when we talk about the state looking at what a district is able to make on its own and pulling that into the formula. So the first part now is called the foundation aid, and this is where we're going to see directly things like property taxes that a district has. We're going to talk about what those state dedicated funds are. That's where a lot of districts that break the formula end up breaking it, is through their state dedicated funds. The second part is the transportation factor. This is actually an equal factor, equal in the sense that everybody gets the same amount depending on how many students they haul. And then the third part is the salary incentive aid. And here again, we take just a little bit of the local property taxes and add that in here. Not as much as we take at the top when we're dealing with state dedicated funds, but we just add property taxes down here. So we have two important numbers here that you're going to hear us refer to throughout this project: the foundation aid factor and the incentive aid factor. These numbers change every year from the State Department of Ed, and this is how the State Department determines how much money it is going to give. So basically what we're saying is, when the State Department makes a request to the legislature for a budget, and the legislature funds that request, however much they fund it, the State Department knows how much money they have to spend on Common Ed. So let's say they have $1 billion they're going to spend. Well, now that they have that, how are they going to try and divide that up equitably among the districts? And to do that, they adjust these two factors every year, and that's how it works. So we're just going to use some imaginary numbers. Your actual numbers that you will use for the foundation aid and the salary incentive aid factors are listed in question number 3 of your answer sheet. But for now, we're going to use $14.59 for our foundation aid and $69.93 for our incentive aid. If we go to our district information, the first couple of items here we're going to look at are the net valuation and the state dedicated funds. So you see here, I've highlighted 2 spots on our sheet. The adjusted valuation or the net valuation, they're the same thing. This is your property taxes, okay? So this is how much money the district generates through local property taxes. And we're going to put it in 2 places. We're going to put it in the foundation side of the formula and the salary incentive side of the formula. And what that's going to do is it's going to be an equity piece, in the sense that we're going to subtract this from what the state is going to give. And again, if a district has a lot of local property taxes, it's going to cut back on what the state gives. And the reverse of that is also true. Now, we're going to multiply this times 15 mills, okay? So we set our adjusted valuation for our imaginary district is $4,118,446. Where we come up with mills, this is how we deal with taxes. A mill is 1/10 of a penny. So when we're saying 15 mills, it's 0.015, okay? 4 mills would be 0.004. So a mill is 1/10 of a penny. Mills used to be used. There's another presentation that shows that. We don't print mills anymore. They're not in use. But we do use them on paper for property taxes. So 15 mills of our adjusted valuation, keep in mind, this means the total property taxes in the district, goes in the foundation side. So we take the 4.1 million, multiply it times 0.015, and come out to 61,776.69. We then move to the bottom, and you can see at the bottom here on part B of the salary incentive side, we take our same 4.1 million. Here we're going to divide by 1,000, and I'm going to explain this to you a little bit when we get on down here why we divide by 1,000. But this comes out to $4,118.45. Next, we take, back to the top, we have our 4 mill county levy. The 4 mill county levy is a holdover from when we had segregated schools in Oklahoma. And what the legislature did was each district would take 4 mills out of the property taxes and dedicate that to the black schools being served in the county. When school segregation became illegal, that 4 mills still stayed on the books. And so there's 4 mills that are taken out of our net valuation, and the district receives 75% of that. So in order to get the $16,000 for our 4 mil county levy, we simply take the 4.1 million and multiply that times 0.004. That's 4 mils. So we generated $61,776.69 on 15 mils. We generated an additional $16,473.78 on the 4 mil levy. Again, the district gets 75% of that, so we're going to add $12,355. Next, we move to what are called the state dedicated funds. These are funds that the state automatically flow through straight to the district. You can see these are school land monies, gross production taxes, motor vehicle taxes, and the REA. The REA tax is your rural electrification, and this is predominantly, we see a lot of this out in western Oklahoma. The bulk of this money for those districts that receive it really come from gross production. And what we're talking about here is districts that have a lot of gas and oil in their district. That tax money from that goes to the state dedicated funds as gross production tax. And we're going to see that when schools go off, they typically are off the formula or break the formula through their gross production tax. In this imaginary district we see the district gets $270,543 from their state dedicated funds. So what we're going to do now to get the total for line 2 is we're just going to add all this together, and we come out with $344,600. And what this means is this is how much money the district is making on its own through property taxes and state dedicated funds. So we call this chargeables. Okay, so our total chargeables, this is a misspelling, our total chargeables are $344,000. So we're going to ultimately subtract that from what the state would give us. The same thing down here in the bottom, as we'll see in a minute, we're going to subtract the $4,118 from what the state gives us. We do this, again, as an equity piece. Those districts that can make more through local taxes are given less from the state. Okay, that's what equity means. Those districts who make less through local taxes are given more by the state. So that's the first part there, looking at chargeables and how we figure out what the district can make on its own through local taxes and state dedicated. Next, we're going to move to the transportation factor, or the transportation aid. Transportation aid is given to all districts who haul students living beyond 1.5 miles of the site. If a district does not haul any students, the district will not receive any transportation aid. This is an equal formula in the sense that money is distributed equally. Simply how many students you have, you're given money. Okay. There's a slight piece of equity in here when we look at part of the formula, and I'll explain that in a second when we look at the density index. But in general, this is an equal piece, equal money for equal students hauled. To do this, we look at the average daily haul and the square miles of the district, and these are located on your information sheet. We're going to use this chart here to figure the density of the district. And so what we do is we take our average daily haul in our imaginary district. We haul 407 students, and we haul them in a district that's 291 square miles. We divide those numbers to find our density. 407 divided by 291. Our density is 1.3986. We simply locate that on the chart. And here we see that it is equivalent to a per capita allowance of $90. Meaning we're going to give $90 for each student that's hauled. Our transportation factor of 1.39 is going to remain the same. Just like the salary incentive aid and the foundation aid, this factor could also change every year. It does not, though. This factor stays the same every year. So let's take these numbers that we just found, 1.3986, $90 for our allowance, and the transportation factor, and put them in our chart. So our average daily haul of 407 students times our per capita allowance of $90 times our transportation factor of 1.39 equals $50,915.70. That's what the district will receive from transportation. And so we're going to insert that into our formula. Okay, now that we've done some background work, we're going to look at what the state actually gives the district. And to do this, we have to figure what we call our weighted ADM. And this goes into two spots. It goes in the foundation aid and the salary incentive aid side. This weighted ADM is what you have in question 1. And this, once we figure out how this works, the rest of that's going to fall into place. Okay? Just like the other, as far as an equity piece, the weighted ADM is an equity piece as well. ADM simply stands for average daily membership. This is how many schools you have in your student. Our weighted ADM means that we realize it takes extra money to educate certain students. And when the formula was created back in the 80s, the legislature put weights into the formula. And so we have grade weights and we have student weights. We also have a little bit in the small school and isolation weights and the teacher index weights. We're going to put all these in, and this is an equity piece in the formula. And what we're saying as we go through, I'm going to explain to you why these things are weighted in the equity piece. Okay, so this is where you're going to work through your packet as well for each of your districts. And we're going to continue to come back to this sheet and insert these numbers as we figure them. So this is the raw ADM weighted pupil grade level calculation sheet. This is the sheet you have in your packet. For the rest of this video, you will not see some of the stuff at the top, such as PK3, half day early childhood 4, full day early childhood 4. These things have been added over the last few years. Okay, so that's why you're not going to see these, but just know that in your actual sheet you need to include these numbers when you're figuring your grade weights for your students. So let's look then at our demonstration data and simply insert this. So you can see we simply inserted these numbers into our sheet. So we had 50 full-day kindergartners, 56 first graders, 54 second graders, and so on. What we're going to do is we're going to add these numbers to come up with our original raw ADM. So use this as your raw ADM, not the number that's listed on your data sheet. This is your raw ADM. The next thing we're going to do is simply carry these numbers over into these specific categories. And you're going to understand in a second why we're doing this. This is an equity piece. So what we're saying is, up here on kindergarten, these students are rated as 1.5. So we know that it takes more to educate students in lower elementary. And you can see that in kindergarten it's 1.5. In first and second grade, the weight is 1.351. In third through sixth grade, or third grade, it's 1.051. And then in fourth through sixth, it's 1, simply 1. And then once we get into high school, we weight them a little bit higher. The reason for this is simple. We realize that it takes more to educate students in lower elementary and in high school. In lower elementary, you have small classes. State law limits the size of classes, and therefore you can't fill a classroom with students. And so it costs more to educate students in lower elementary. In high school, it costs more because you have specialty classes such as things like, maybe you're taking calculus or an AP course or a foreign language course. Courses that are not required to take, but that are electives, and whereas your American history course is probably full with 30 students, your AP US history course may only have 12 students in it. And because those classes are lower, we realize it costs more money to educate students in high school. So that's why we weight that factor. And we simply just add up these totals and then do the math. So when we add the totals, you can see what we have here. Now, up here on this part, you would just carry everything over. But here we have 110 students in first through second grade. So we're going to multiply all these by our factors and carry them over. So you can see how we've done that. And then we're simply going to add all these together and we're going to get our grade level weight. So here we have our original raw ADM, and now we've weighted our students and we have 740.86. When we subtract our original raw ADM from our grade weight, we get a grade level weight of 118.86. Okay, so that's what we're doing here. We're subtracting the original raw ADM from our grade level weighted ADM, and we get our grade level weight of 118. So now we have numbers we can start inserting. 622 for our raw ADM, 118.86 for our ADM grade weight. And we can add them together. So this is going to be a running total until we get everything completed. So we have 740.86 students so far. Now let's look at pupil categories. Those are grade weights. Now we're dealing with pupil weights. And pupil weights, specifically here, we know we're looking at basically 3-4 different areas. We're looking at special education. We know that it costs more to educate students who are receiving special education services. We know that it costs more to educate students who are gifted. We know that it costs more to educate students who are bilingual. And we know that it costs more to educate students who are economically disadvantaged. These are your free and reduced meals students, or as I like to refer to them as your farm kids, free and reduced meals. These are your Title I students. Okay, so as principal, you are the one responsible for entering all of this information correctly into the State Department website so that we can get an accurate count of our student enrollment on October the 1st. So we go to our sheet, we pull these numbers from our sheet, and we simply insert them where they are. If we don't have anybody, then we put it as a 0. So notice that these categories have slightly changed over time. For example, I think I've updated everything. Physically handicapped. Used to we had OI and OHI. Now we've just combined it for physically handicapped. We used to have EMH and TMR. Now we've combined it simply as MR. And so once we put these numbers in, we just multiply across. And this gives us our pupil categories. And again, we're going to do certain things here. First of all, we're going to add our special education weights together. And we get a special education weight of 37.9. We take our gifted, our bilingual, and our Title I or our farm kids, and we add all that together, and we come up with pupil category of 152.81. And we're going to transfer these 5 numbers, including our summer special education program, over to our chart. And there you can see where we've simply inserted them in. Okay? And we've updated our running total. Now we're up to 893.67. So that's the equity piece when it comes to students. We look at grade weights and we look at student categories. Now we're going to look at school size. And school size, this is the formula we use for school size. There are actually 2 formulas here that we're going to figure. and you only get one or the other. You don't get both. Most school districts don't get either. Okay, so keep that in mind, that you can have 0 on both of these. That's a very common thing. We're going to look at small schools, and we're going to look at isolated schools. Small schools from an equity perspective. I graduated from a small high school. I had 12 students in my senior class. It was a very small school. So my English 4 class had 12 students in it. Whether or not my teacher had 12 or 30 that somebody may have in a Tulsa public school or Broken Arrow or Union, that teacher still is paid the same salary and has to teach the same subject. So this is why we give small schools, small in the sense of numbers, student numbers, an advantage, because the district has to continue to pay that salary for that teacher, even though they're teaching less students, and in theory they have less students, which means they're drawing less money. So we figure the small school weight. Then we look at the isolation weight. Isolation weight means how spread apart the district is. So here we're looking simply at the size of the district and looking at the number of students within that district to see if we can consider them isolated. Isolated in the sense that a district that's extremely spread apart, say 400 square miles. We have districts that large in Oklahoma. These districts are typically going to be rural districts, and in order to provide opportunities for those students to learn about things that we call such as cultural capital, how are they going to be able to view a museum, come to urban areas and experience life in urban areas, those things. We realize that it's going to cost the district more money. Even the sense of getting the students together in a large isolated district is going to cost the district more money. And so therefore we want to help compensate that, and so we calculate the isolation weight. So we have small school weight and isolation weight. You get one or the other, you don't get both. So in order to do this, we look at our average daily membership, which actually you received from the other page, not this page. This is a correction I need to make. And our square miles, how large our district is. So here, this is where I want you to get your average daily membership. On this page here, I want you to add these numbers together and get your average daily membership. So what we're going to do then is simply start to insert these numbers. So here in our district, our average daily membership was 622. Our average school is 529 raw ADM. We simply do the math. The most common mistake here is that people forget to divide by 529 after they subtract. So we're going to subtract 529 from 622. Divide by 529, we get a negative number. Once we start with a negative number, we know that it's going to end up as a negative number through math. Anytime you have a negative number, it's automatically 0. Keep that in mind. But let's go ahead and continue the calculations. We simply multiply then by 0.2. Multiply that again by our raw ADM. And again, we knew we were going to get a negative number. We change that to 0. So we don't get a small school weight for this district. Now let's look at the isolation weight. And I want you to listen carefully as we go through this. This is very simple. It's a lot of little math, but for most of them it's going to be very simple. So let's start with part A. If the school district's total area in square miles, ours is 291, is greater than the state average of 129, go to the next step and compute areal density. If the district has less than the state average, go to paragraph D at the end of the weighted calculation. Anytime you automatically go to paragraph D, that means it's 0. Okay? So we've made it through part A, so now we're going to go to B, because A said if your district is greater than the average, go to part B, and we do that. So 291 is greater than 129. So let's go to part B. In part B, our density, we take our raw ADM of 622 divided by our total square miles of 291. Our density is 2.137. In other words, we have 2.137 students per square mile in our district. If the school's area density is less than 2.21, calculate the district sparsity isolation formula as follows. If it is greater than 2.21, go to paragraph D, and we enter 0. Okay, so anytime it says go to paragraph D, the formula is 0. But ours is not. Ours is actually slightly less. 2.137 is slightly less than 2.21. So we're going to go ahead and calculate our isolation formula. Okay, so now we're in part C, and you can see we've slightly changed our grade categories. So let's move forward and simply insert numbers. We're still going to pull these from our previous sheet, but we're not going to organize them this way. We're going to organize them differently. And so I have them highlighted here how we're going to organize them. Kindergarten through 5, 6 through 8, and 9 through 12. And we're simply going to add them together and then transfer them over to our sheet. Okay, we're going to put them up here. We're going to put them right here. We have some numbers already in. We know what our raw ADM is, and we know how large our district is. Okay, so we're just going to do the simple math as we go through. We're going to add these respective numbers and come up with our new numbers. Okay, so 311 for early childhood through 5th grade plus 23 becomes 334. We're going to move that down to CA. Okay, or that becomes CA. 74, we're going to carry out these calculations. 74 divided by CA. So 74 divided by 334. 122 divided by 274, 292 divided by 298, they equal, we get these decimals. We're going to add some more decimals to them. Then we're going to multiply by our numbers. And we have cost factors now. We need to add up all three of our cost factors to get a total here for number 4. We have a cost factor of 815.5 divided by our raw ADM is 1.31, and we're going to subtract 1 from that, so our district cost factor is 0.31. Okay, now let's look and figure our area factor. Different numbers, lots of using the word factor, but in number 5, we take our district in square miles, subtract 129, again that's the average, and divide by 129, and we come up with an area factor of 1.26. Now in line 6, we multiply our district cost factor by the lesser of our area factor, or 1. So our area factor is 1.26. Our which is higher than 1, so we're going to use 1. So we bring down our district cost factor, we bring down our area factor, and since 1.26 is higher, we simply multiply by 1 and get 0.31. That is our isolation factor. Now we take our isolation factor, multiply that times our raw ADM, and this gets us an isolation weight of 192.82. That is pretty significant, okay, and we'll see why that's significant in a minute. So now we simply go to part D, Again, for most of them, at any point in the isolation weight, if it said go to Part D, you would enter 0 here as the isolation weight. But in our case, we didn't. We had an isolation weight. Now, our district weight was 0. But we had an isolation weight of 192.82. You can take one or the other. Again, most districts don't get either. Some districts have small numbers on both. And you take the highest one. Okay? And so we're going to take 192.82. And we're going to bring that over to our running total. We're going to add that in. Okay? And you would simply put, for your small school weight, put 0. The last thing we're going to look at for weighted ADM is our teacher index. And here you have information on your teachers, their years of experience, and their degrees. This is simply a matter of putting in the numbers. Okay, so you can see I have 0 years of first-year teacher. I have 1 with a master's degree. I have 4 teachers who are in their second year with a master's degree, and so forth. I'm going to do the calculations with these factors. I'm going to add both columns as I go across. So I have 17 teachers. My factor comes out to 18.8. I'm going to do the same with bachelor's degrees. I have 33 teachers. My factor comes out to 31.4. Now we're going to figure this bottom part. The teacher index is actually the one where most people miss. Okay? So we're simply going to add our degree index. This is what we use with the factors. We come out to 50.2 divided by our number of teachers, 50. And this equals 1.0040. Okay, rounded to 4 places. This is the only place that specifically says to round to 4 places. This is our weighted average district teacher. Okay, 1.0040. We're going to subtract our district teacher index, and this will stay the same. This can change every year, but I want you to use 1.1037. I have an extra decimal in there, 1.1037. So our weighted average district teacher of 1.004 minus 1.1037 equals our school district teacher index, okay, which is a negative number. We know that our end is going to be 0, but let's carry out the math. We multiply our school district teacher index by 0.7, and then here is where I had some clarification in the past when it talks about the grade weight ADM plus the economically disadvantaged. The grade weight ADM here is your raw ADM plus your grade weight. So all that together equals your grade weight. And then we're going to add in our economically disadvantaged weight. So here, from this district, our grade weight, our raw ADM plus our grade weight was 740.86. Our economically disadvantaged students was 98.25. We add those together and then multiply that times our previous number, and we come out with a negative number. So we know this is 0. If it were a positive number, we would add that in. Okay? But since it's not, we keep it 0, and so our total comes out to 1,086.49. Now, we go back finally to our first page, and we're looking at our weighted ADM, and we can add that in at the top and do the math. And what this means in the foundation side of the formula is the state is going to give this district $1,585,188.91. But remember, the district has to subtract what it could make on its own through property taxes and state dedicated funds. So that's why we subtract line 2 from line 1, and the total on the foundation side is $1,240,000 and some change. If this number were negative, you change it to 0. You have to change it to 0. Okay? Otherwise, you would be indicating that the school district pays the state back the extra money, and we call that recapture. And that has been proposed in the legislature, and we don't have that in Oklahoma yet. Some states do, but we don't have it in Oklahoma. So that's why we changed that to 0 if it's a negative number. So that was just highlighting what I just told you. Now we do the same on the bottom. Take our incentive aid factor of 69.93, our weighted ADM of 186.49. On the incentive aid side, the state is going to give us $75,978.25. Previously, we divided our local taxes by 1,000. Now we're going to subtract. Again, this is a small equity piece in the sense that the state is subtracting a little bit of what the district can make through property taxes to adjust for equity. Now, this says multiply by 20 mils. Okay, earlier I told you a mil is 1/10 of a penny, so it looks like we should multiply by 0.02. But actually, when we divided by 1,000 up here, we changed this from 0.02 to simply 20. We took away the decimal place when we divided by 1,000. So actually what we're going to do is multiply it by 20. And it comes out to 1.4 million. And so the last thing then is we add our information together. So we take our foundation aid, our transportation, and our salary incentive aid and add them all together. Now again, if your salary incentive side were a negative number, we would change it to 0. You have to change it to 0 because otherwise it's going to subtract. Okay, these stand independent of each other, each of the 3 portions. That's why you have to change it to 0. So our total state aid for this district then becomes $2,728,625.49. So one last comment on why we do this, and keep this in mind when we're dealing with schools. The major thing about school finance is anything that deals with how schools are funded. We don't just give a district money. Everything is translated into students. Okay, that's what the weighted ADM is. So if we say that it costs more money to educate a student who has special needs, maybe an autistic student, or students who are being served by free and reduced lunches, or to run a school out in western Oklahoma or southeastern Oklahoma, isolated, or a small school, or if the school has a lot of highly qualified teachers and with advanced degrees and it costs them more. We can't just give money. We have to turn everything into students. Okay, that's how schools receive money, is by students, and that's what this weighted ADM is. We translated everything into students. So when we talked about the fact that the school is isolated, well, what is the equivalent of that in students? It's 192 students for our demonstration district. When we talk about student categories, we saw we had some special ed students, we had some gifted students and economically disadvantaged students. What does that mean? We can't just give money, we have to translate it all into students. And so we translated that into 150 students, plus or minus, I forgot what it was. But that's what weighted ADM is. And as far as school finance goes, the weighted ADM is the piece that translates all the needs of a school into students. Okay? So hopefully that's as clear as a nice mountain spring on how we figure state aid for Oklahoma.